We are Group L from Section 01 will be presenting about our mini project Leaf Controller. I will start with a brief introduction on every component of Basic Circuit 1. The circuit's inputs consist of input X is for the up-down synchronous counter. 1 is up and 0 is down. Input CLK, input power, and input start are combined into AND gate and connected to the clock of each flip-flop. Users can enter the level that they want to go by using inputs A0, A1, and A2, which leads to 7-segment hex display, and these inputs are also used for comparison. We are now at the output sections. Output includes Q0, Q1, and Q2 are the output that will display either 0 or 1 and connected to 7-segment hex display. From the comparator circuit, by using input A0, A1, and A2, it will determine whether the door will close or open. As for the advanced feature, we have password. When using a lift, a password is required for the security system. Since the password has 3 digits, so we use 2 comparator in the circuit. Each comparator's output will be connected to input X, power, and start.
Now, let's explore the functionality of this fundamental circuit tool. Illustrating its role as a leaf system, we have incorporated flip-flop E, which share the same configuration as flip-flop D, with the sole distinction being the presence of an enable input. To set the circuit in motion, it is imperative to design and enable as 1. Additionally, ensure that the power, start, preset, and clear switches are also set to 1. Specify the desirable level and input the password 152 to prevent any potential errors. When ascending from a lower level to a higher one, set switch X to 1. Conversely, if descending from a higher level to a lower one, set X to 0. To enhance the circuit's capabilities, we have integrated a password requirement for user access and an LED indicator to display whether the door is open or closed. The password 152 serves as a comparator, allowing leaf usage only upon correct input. The LED is connected to the comparator, comparing the selected destination level with the current level. For instance, if using the leaf to travel from the ground floor to level 7, ensure enable, power, start, preset, and clear are all set to 1. Don't forget to input the password 152 to activate the system. To initiate an upward journey, set X to 1, placing the circuit in counter up mode. Press the clock button until reaching level 7. Observing the LED indicators, the one signifying the closed door illuminates when not yet at level 7, such as at level 1, 2, 3, 4, or 5 or 6. Conversely, the LED indicating the open door activates upon reaching level 7. This is determined by the comparator, which output 1 when the selected and current leaf level different and 0 when they are matched. To properly interface the comparator output with the door open LED, it is necessary to invert the comparator output.
Next is our circuit 2. Instead of using logic gate for our circuit 2 use bus component and up-down synchronous counter to connect all the wires, so that our circuit seems simpler than circuit 1. An up-down synchronous counter is a digital circuit capable of counting both upwards and downwards synchronously with a clock signal. It provides versatility in applications requiring bidirectional counting, offering efficiency and accuracy in tracking processes or events in electronic systems. Based on the diagram shown, a bus is actually a common wire which is connecting to various points in a circuit. The bus comparator must be connected with bus connections. Hence, our advanced features consider more enhancement, which consists of password for security and LED lamp for the convenience to its user. Surely, someone will have the password will only have the permission to enter the loop. Also, the LED will light up when the door is open and closed. The useful of LED installation toward the lift will help in reducing of energy consumption, which is one of the smartest moves that will active when the lift is in need. Next is our circuit 2. Instead of using logic gate for our circuit 2 use bus component and up-down synchronous counter to connect all the wires, so that our circuit seems simpler than circuit 1. An up-down synchronous counter is a digital circuit capable of counting both upwards and downwards, synchronously with a clock signal. It provides versatility in applications requiring bidirectional counting, offering efficiency and accuracy in tracking processes or events in electronic systems. Based on the diagram shown, a bus is actually a common wire which is connecting to various points in a circuit. The bus comparator must be connected with bus connections. Hence, our advanced features consider more enhancement, which consist of password for security and LED lamp for the convenience to its user. Surely, someone will have the password will only have the permission to enter the lift. Also, the LED will light up when the door is open and closed. The useful of LED installation toward the lift will help in reducing of energy consumption, which is one of the smartest moves that will active when the lift is in need.
Okay, so now I will demo you on how we run our circuit, basic circuit 2 with advanced feature. First of all, the power and start and enable also clear must be 1 because you want to turn it on. And the S, I will show you how we going up first. So the S must be 1. And we choose the level. The level, I want to go to level 3. So I will choose 3. And we must put our password. For the password, if we put the wrong number, the lift will not be run because it's also like security. Okay, then we already done. So how do we change the floor? Because right now we are at the ground floor, the door is still closed. So we must the clock is the how we change it. We press the clock and now it display as 1. We are at floor 1 and the door is still closed. We press it again and it display we are at floor 2 and the door is still closed, and we press it again. Now the door is open because the floor is at floor 3 and we want to go to floor 3, so it arrived at the destination. Okay, now I will show you on how we are going down. The S must be 0. Okay, and we change the level at 1. Okay, so now the door is closed. Okay, so we press clock. Now the floor is at floor 2, but the door is still closed because we want to go to level 1. So we press it again and now the door is open because we have arrived at the destination. How it's different with basic circuit 1 advanced feature is because we use bus line, the output we connect with the comparator of our input level with bus line and counter for our power start enable and clear. So with bus line. So that's all from me. Thank you.